Okay, in this recording, we are going to work a couple of more examples. Okay, we have a ball of mass 0.2 kilograms that is tossed with a speed of 20 meters per second, but there is a twist here at an angle of 60 degrees above the horizontal and from a height of 1 meter. So if this is ground level, this is the person doing the tossing. So the ball is going to be tossed from 1 meter and it's going to be tossed at an angle of 60 degrees above the horizontal. Now, they tell us when it reaches the highest point, the ball is going to follow this path. At the highest point, its horizontal velocity is 10 meters per second. That's what they tell us. And then they are asking us what is the mechanical energy relative to ground, what is the mechanical energy of the ball relative to the ground the instant it is tossed. Now, the purpose of this question is to stress the point that the direction of the velocity here is not important. Now, mechanical energy is kinetic energy plus potential energy. And remember here, since we don't have a spring, it's going to be just gravitational potential energy. And that's going to be, the kinetic energy is going to be 1/2 of mv squared. We know m and we know v, so that's easy. And the gravitational potential energy, they told us relative to the ground, so it's mgh, where h is the height relative to ground. So we can just plug in these. So that's going to be 1/2 for the mass 0.2 kilograms times 20 meters per second squared. That would be my kinetic energy, plus 0.2 kilograms times 10 meters per second squared for g, times 1 meter for the height. So in this case, we get, let's see, 20 squared, that's 400, I believe, times 0.2 divided by 2, so that gives us 40. So we have here 40 joules, plus from this other side we have 10 times 0.2, that gives us 2 times 1 plus 2 joules. So altogether it's 42 joules. That's my mechanical energy at the beginning. Now, the next question is, what is the mechanical energy when it is at the topmost position, at the highest position? Now, since we have no losses due to air resistance, the mechanical energy is going to still be 42 joules. That's conservation of mechanical energy. Then the question is, what is its kinetic energy when it is at the highest position? Now here it's a little more complicated because let me take that back. Here, to find the kinetic energy, since we are given the speed at that position, it should be an easy problem where we can just calculate the kinetic energy as 1/2 of mv squared. So in this case, that's going to be 1/2 of 0.2 kilograms times 10 meters per second squared, the speed at that point squared. So 10 squared is 100, 100 times 0.2 divided by 2, that gives us 10 joules. So the kinetic energy that it has when it is at the topmost position is 10 joules. And its mechanical energy is 42 joules. So The next question is asking how high is it? Before getting how high is it, we can focus on the fact that the mechanical energy is 42 joules, the kinetic energy is 10 joules, so where's the rest of the mechanical energy? Where does it come from, the 32 joules? Of course, since we don't have anything else involved, it's going to come from the gravitational potential energy. So this tells us that the gravitational potential energy when the ball is at the highest position is just 32 joules. And then since the gravitational potential energy is mgh, so mgh is equal to 32 joules, I divide both sides by mg. So in this case we get h then equal to 32 joules divided by m, which is 0.2 kilograms, times 10 meters per second squared. 0.2 times 10, that gives us 2, so that gives us 16 meters. So h is 16 meters, or the highest position of that tossed ball or that tossed mass is 16 meters. Okay, let's try to work another example. Okay, this is also another example. Try to get you to look at another angle. In this case, we have a pendulum that's made up of a 2-meter long string and a 0.1 kilogram mass. If this is the equilibrium position, they tell us when pulled at an angle of 60 degrees relative to equilibrium, the mass is then 1 meter above its lowest position. They tell us this is 1 meter. Then the question is asking us what is the mechanical energy of the mass relative to the lowest position the instant it is released from the 60-degree angle position. Now that's an easy problem again. Mechanical energy is gravitational potential energy plus kinetic energy. It is released from that top position. That means the kinetic energy is 0. The gravitational potential energy is mgh, so that's going to be mgh plus 0. Now, what would be the mgh? It's going to be .1 kilograms, the mass, times the 10 meters per second squared, times the 1 meter above the lowest position, since they told us to get it relative to the lowest position. So 10 times 0.1 is 1, so this gives us 1 joule. So our initial mechanical energy, or mechanical energy at the initial position, is 1 joule. Then it is asking us what is the speed of the mass at the lowest position. Now at the lowest position, my mechanical energy is still going to be equal to 1 joule. But my mechanical energy in this case is going to be, let me write it down as an expression first, EPG plus EK. EPG is going to be 0 here, because we are measuring the gravitational potential energy relative to that point, to that level. So this is going to be 0. And we are going to be left with just the kinetic energy. So my kinetic energy is equal to 1 joule. EK is 1 joule. But what EK is 1/2 of mv squared. Then is equal to 1 joule. So I can use this to solve for V. V squared is then equal to 1 joule dividing both sides by 1/2 of m. Okay, and that's going to give me 1 joule over 1/2 times 0.1 kilograms. So that gives us 20 meters squared per second squared. And I take the square root of that to find the speed. That gives us 4.5 meters per second. And that would be the speed of my mass when it is passing by that point.